Hi everyone, my name is Charles Tian, and in this lecture, I'll be talking about how to determine if a DNA helix is right versus left-handed. So I'm covering this topic because I had a lot of trouble visualizing and understanding this when I first started. So I'm going to give you some tips and tricks that I have learned to help me how to define and determine. So this is the so right here in this picture, this is the classic way in trying to determine the handedness of DNA. You use your right hand and then you point your thumb up and curl your finger. And using that curvature, that rotational orientation of your fingers, and then if you look at the DNA, if that term follows that curve, then it is a right-handed DNA. You can see how the curve is curving inward, going up. But I found this is really confusing, especially in a test and you have to use your hand. It gets stressful. It is hard to visualize this, especially when the DNA is 2D on your exam paper. So a way that I have learned to do this is simply looking at um, the DNA strands. So I'm going to use picture A and B as example. So for A, these strands, you want to take the ones that's the closest to you. Right, for these two. These two are closest to you, and these two right here, like this one right here, for example, it is further away. It's on the back. Just think about it in a 3D sense. So you want to take the two strands that's the closest to you, and then you want to draw the slant along it, and you want to draw it on the near it, on the other side, of the paper. And if you look at it, ascending the DNA, so from going down to up, if the slant is lower on the left side, higher on the right side, then it is a right-sided DNA, right-handed DNA, right? The lower side is the left side, the right side is higher. It is slanting upward to the right. So it is a right-handed DNA. For this one, if you draw the line again, this is a left-handed DNA because the bottom is on the right, the top is on the left, bottom on the right, top is on the left. So if the top is on the left, then it's a left-handed DNA. If the top is on the right, then it's a right-handed DNA. Another way, which is even more intuitive to think about it, is that think about it as a staircase. Well, so a little person is right here, and he wants to walk up this staircase of DNA. So as he's walking out, he needs to hold a railing for support, so he's gonna grab onto this right side of this DNA. See? So because there's nothing on the left side for him to grab on, right? So you want to visualize this as a staircase because DNA already have these base pairing ladders, so it's almost like a staircase. So imagine this little guy trying to walk up the DNA. He has to grab onto the right side railing. So this is a right-handed DNA. Another example, if we look at DNA strand number B, if the little person's here, well, he has to grab onto the left side of the railing. So he is using his left hand to grab the left side railing. So this DNA is left-handed. Again, for A, the little guy has to use his right hand to grab the right side railing. So the DNA is right-handed. And a quick note in applying this to more biochemistry knowledge, biochemistry topics. So you have these main three forms of DNA. B form, which is a standard form of DNA. This is a right-handed DNA. You can see the strands. You can see how it is slanting to the right. A form is also right-handed. You can tell, even though this is more compact and shorter than the B form DNA, it is still running to the right. The Z form is different because even though it's a zigzag, if you imagine it as a straight line, a slanting line, this is actually completely different. It's the opposite from A form and B form because now the lower side is on the right, the top side is on the left, so this is a left-handed DNA. And so this is an application of this little trick to help you determine whether a DNA is right-handed or left-handed. So yeah, I hope you learned something new. And learn an easy way to visualize and understand how to determine if the DNA is right or left-handed from this lecture. And thank you so much for watching.